So here it is. You guys could download it. This is fall 2020. The structure is very similar to how we teach it on campus. And if we didn't have this COVID pandemic going around, we would be on campus. So the core of the syllabus is still based on you guys coming to campus and learning in that modal. But of course, we are doing remote learning. And so anything that pertains to you guys doing activities on campus, you could ignore. And I've tried to modify it so that it addresses how we are learning or how we're delivering this course uh, through Zoom, but uh, I may not have picked up all the sections that refers to that or modified that section. So you guys are just going to, when you read it, just kind of assume that you were taking it on campus and know that, of course, we are doing our lectures on Zoom. So here's the syllabus. The first part of this information right here is, let's see if I can find an ink pen. This part is just information in terms of my contact. You can contact me through the email system in Canvas. If you open up Canvas, there's an email system there. That's the best way to contact me. That way, everything's in one area and it won't get lost in my stack. The other way to contact me is fgarces.ch201@gmail.com. Try and use that, and not so much my SDCCD account, just because that tends to be full with other administrative stuff, and that tends to be the last one I check when I'm looking at my email. So again, use Canvas email system or my Gmail system. Then of course there are, you find this course in Canvas and it links to my website that basically mirrors Canvas. Now, because we've had some issues, technical issues, my website is not completely up to date in terms of the link, because I have to convert it from spring to fall, and so some of the links and names there need to be modified. And that means that Canvas may have a broken link as well, because it's pointing to spring 2020 instead of fall 2020. So you just have to be patient with me. It should be complete by this week. But again, if there's a dead link or a link that doesn't go to the right semester, know that it should be fixed by the end of this week. If it isn't fixed, then I'm sure you guys will tell me. There's also a tool in Canvas that will look for broken links. If you guys have any questions, just
okay, thank you.
And you guys can speak up. But usually my
Yeah.
I can hear you guys talking, okay, is that I silence you as you enter. So please keep that in mind when you enter, is that I try and mute you guys, and then if you want to speak up, then you just unmute yourself, and the controls are at the bottom of the screen. Okay, so like I said, this is make sure that you guys are still seeing course syllabus. Yep, you guys are still seeing course syllabus. So yeah, change things a bit. This to the side. Okay. So the next part of this is just what this course is about. It's the second semester of general chemistry. General chemistry is really more math-based. We like to call Chem 201 baby PChem because there's a lot of physical chemistry involved. We're talking about kinetics, equilibrium, thermodynamics. You're talking about the physical process or the physical phenomena of a chemical reaction. And I'll talk more about that shortly. So there's a lot of math. For those of you who like math, great. For those of you who are hesitant, you're going to have to learn quickly how to do cube roots or power to the fourth or quadratic, because those are some of the fundamentals. Even though we do integrations, the solutions to the integrations will be given to you. And so you don't have to carry out the calculus. You just have to work out, you just have to use the solutions. Okay, so let me go ahead and go through this. In terms of the textbook, for those of you who didn't take Chemistry 200 at Miramar College and didn't purchase this book for first semester, then you're going to have to sort of go and purchase your used copy or
Bye. Thanks, you too.
someone's still talking in the back. I thought I muted everybody. So just mute you all. Okay. All right. So let me go ahead and um, tell you about the materials. And for those of you in lab, you don't have to buy protective personal equipment because you guys are not going to be in lab. It's going to be like last semester. I think for those of you who took general chemistry last semester, you saw it was mostly video based. So that's what we're going to be doing as well. You guys don't have access to chemicals, you don't have access to glassware. So the emphasis here is to watch the video, watch how the data is collected, and then make sense of the data that is collected. But I'll talk about that in the lab section. Here, what you guys will be doing is just learning the fundamentals of general chemistry through Zoom. Now, what you will need is this text right here. You see the icon of the book. And if you don't have that book, then you should go to web My Lab and Mastering. There's a link on the left of Canvas. Click on that and then just follow the trails. There's also a video on how to register, but you can sign up for a 14-day trial. At the end of 14 days, if you don't pay the publisher, then they will lock you out. Okay. Now, you definitely need to purchase the My Lab and Mastering, but you need not purchase the new edition of a book. You could actually use an older edition. Chemistry is chemistry. It's not going to change on you. Okay, so keep that in mind. Just see what's going on. Keep hearing someone clicking. There's no one in chat, so if you guys have a question, you can certainly put something on the chat. Okay, there's about 36 of you here, so that pretty much is the class. So going back to materials, again, My Lab and Mastering, you can access that through Canvas. On the left menu, you click on that and just follow the trail and you could register. If you've already purchased My Lab and Mastering, then don't purchase another code. It's good for a year. So the first semester, use your same ID code and you'll be able to access My Lab and Mastering for the second semester. So that's basically what you will need. I don't need Scantrons because you guys are all taking the exam online through Canvas. So you could ignore that if you come up on that particular verbiage in the syllabus. The other thing that you should remember is that you guys should know how to use your calculator. And if you're in second semester general chemistry, then you've already learned how to master your calculator. More so here, just because you guys are going to be doing cube roots, power to the fourth, power to the fifth, things like that. So if you don't know how to do that, please ask and we can have a personal Zoom meeting where I can show you exactly where that function is. Another thing about calculator is that you need to learn how to use the EE key or EXP key, not the scientific exponent key, okay? Because sometimes if you don't type in your numbers correctly in your calculator, you'll be off by a factor of 10. So keep that in mind. Moving along, okay? Yeah, for those of you who keep asking for the course ID, and I've already looked at who's registered in my lab and mastering, and there's a few of you, and a few of you who are registered in my lab and mastering did not need the course ID. There is no course ID in my lab and mastering because when you register through Canvas, it ties in the Canvas page, the Canvas site, my Canvas site, to my lab and mastering. That way, whenever you do your homework, the score that you get through my lab and mastering transfers it directly to Canvas. So that's why you have to register through Canvas in order to get my lab and mastering, okay? There is no course ID, so don't ask me about a course ID. If you have technical issues, then you can certainly talk to me and I'll talk to the publisher as to why you're not getting in. We've had that issues in the past where there's just a glitch, okay? And the publisher or the person who's responsible just needs to go in there and add you by hand. But there is no course ID because we're not going through that route. There's two ways to register in my lab and mastering. And one way is that if you don't tie it into Canvas, you need a course ID. I'm tying it into Canvas, so there is no course ID, okay? So I just want to make sure that that's clear. Set here, okay? And yeah, the ebook is just a digital version of the textbook. And again, you guys are going to be taking it online, and it's going to be open book. It's not open friends, and it's not open Chegg. Okay, we've had a number of issues with students being subscribers to Chegg, where they just have people there do their exam, and we've already talked to the people, and the vice president of student affairs has already sort of figured out a way to make sure that doesn't happen. Okay, so you guys are the main idea is you guys are going to go into, if you're in 201, you're going into science. You really need to learn the fundamentals. And you might say, yeah, but I'm not going to be using chemistry again in the future. The idea here is you got to be able to learn abstract concepts that might be out of your field. That way, when new things come in, you'll be that much more trained to make the adjustment, okay? And chemistry is, at least this chemistry, uses a lot of your upper level thinking in trying to negotiate the language and the behavior with the mathematics. And so if you're going to be a scientist, whether it be a doctor, an engineer, chemist, biologist, then this is a really good course to kind of tie that all together, okay? It's one of my favorite courses to teach just because the math in this course really speaks to the chemistry that's happening. When you're talking about, is the chemical reaction going to give you a lot of products or very little products, you look at a concept called the equilibrium constant. And that is an indicator of the efficiency of the reaction. Whether or not the reaction is going to happen or you need some external energy to make it happen, that's a thermodynamic phenomenon. So again, the math is critical to kind of give you a mathematical explanation of what chemistry is occurring. Moving along right here, okay, you'll see that just make sure that I'm reading the chat correctly. This is the schedule. Now, you can see the first day is just the syllabus and the course expectation, and maybe Chemistry 200 as a review. And the reason why I bring Chemistry 200 in as a review is because the fundamentals are there. Now, if you took shortcuts in Chemistry 200 and didn't learn anything, this course will be a struggle. okay? Chemistry 200, you need to know what are the common polyatomic ions. If you don't know the common polyatomic ions, then you don't know how a chemical breaks down in water and how much ions or how much of it dissolves, because that's one of the things that you guys will determine in this course. What is the solubility? Not whether it's soluble or not, but how much of it dissolves. And you need to know the chemistry of how that chemical breaks down to its ions. And it doesn't always break down to its element, those monoatomic uh, elemental ions, because some polyatomics are very stable. So you need to find yourself a good list of polyatomic ions, because you will need to know that that is stable in water. For example, if I have sodium phosphate, then sodium phosphate is Na3PO4. That's because phosphate, PO4, has a -3 charge. So you need 3 sodium with a +1 to counterbalance the law of electrical neutrality. So if you put that in water, what are the chemicals that it separates to? And I've had students in the past say, okay, sodium is one of the chemicals, and that's logical, that's a cation. Then they take phosphate and break it out down to phosphorus and oxygen, and that's a big no-no. Phosphate's a very stable ion. It's connected by covalent bonds. Those bonds are very strong, and it doesn't break up to phosphorus and oxygen. It stays as a phosphate ion. So those are the things that you guys learn in Chemistry 200 that you will bring here. And I've got a list of things that you should know from Chemistry 200 that we will use in specific chapters. Okay, so I just want to bring that to your attention. So going back here to the schedule, okay, we meet Mondays and Wednesdays, and a lot of times I'll just give you an overview of what that section is about, maybe go into details of some of the calculations, but really it's up to you to kind of like, and I understand that it's difficult when you have to learn things on your own, and that's why we do have these Zoom sessions, so that I can at least clarify it for you so that it makes sense. Too many times the words just go through and doesn't mean anything. You actually need to hear the explanation. And it's too bad we're not in person, because then I can gauge the glaze in your eyes, or the yawn that you do, as to whether it's interesting or hitting home, or whether or not you are getting it. Okay, but at least we do have this technology so that you guys can hear me, and when I get my iPad working, you guys can see how the calculation is worked out. But anyway, what we will do is cover some of the fundamentals that you guys should have covered towards the end of Chemistry 200. Now I realize not everybody had abundance of time to complete all the topics in Chemistry 200. That's why we're covering those topics here, at least reviewing it. And those are intermolecular forces and solution chemistry. Solution chemistry is pretty important, just because if you don't know how to calculate a concentration, you're going to be in big trouble in this course, okay? Because in this class, we do a lot of solution chemistry. Okay, we need to know what the concentrations are. We need to know how many moles of these ions are in the solution, and then that way you can calculate the mass of the product that forms, or the mass of the reactant that dissolves. So you need to know how to calculate concentrations. So that's the first two chapters. Now in my lab and mastering, I have a prime. That is, there's a topic in my lab and mastering where it's given to you before we even hit that particular chapter. And what you need to do is take it, it doesn't count against you, and see how much of that topic you know. What you might want to do is just peruse the chapter real quick and then take it. Whatever points you get, okay, because it does have a point value, will roll over to the main homework. Then after the primer, you have your main homework through my lab and mastering, and that's worth 10 points, okay? And then on certain topics that's really tough, the AI in my lab and mastering will go through what you did wrong or what difficulties what topics you had difficulties in the main homework, and then it'll make some sort of evaluative recommendation. And so that will be due 2 days later after the due date of the homework. So each homework's worth 10 points. If you score like maybe 2 out of 2 in the primer and 2 out of 2 in the post-evaluative recommendation, then, and you score say a 9 out of 10 in the homework, you don't get 13 points, you get 10 points, okay? But you get a maximum of 10 points for each one. If you score over, you get 10 points. If you score like a 4 in the homework, 2 in the primer and 2 in the post, then 4 plus 4 is 8. I'll round up to 8, up to 10 points for each homework. And then for each homework, you get to do it a number of times. I forget whether it's 3 or 5. So it's to your advantage to go in there and try the first time, see which one you got correct, and then correct the ones that you got mistaken, okay? Because you want to maximize your points. This course is really about a course to about 650, 600 points. If you get that, you pass this course. If you want an A, then you need a minimum of 899 points, okay? Now, I give you that as a scale in the beginning, but I generally curve it depending on how the class does. Last semester, because there was so much cheating, the curve really went up. People who were getting B's pushed the curve all the way up. So I wasn't able to lower the A to 880 points. I stuck to 900 points, okay? And yeah, there was a lot of cheating because the people who got the highest in the ACS exam were the ones who never got a B grade or anything in any of the regular exam. So trying to deal with that this semester, okay? So hopefully you guys are not going to cut corners, because if you do, then you just cheat yourself. I wish I could just give everybody an A. That way we don't have to work with grades, but unfortunately that's not how the system works, okay? But if you just keep up with the work, you should be able to pass this course easily. And depending on how much you master, you should be able to get the grade you deserve, okay? So going back to the schedule, I was going to tangents like that, so you're gonna have to excuse me. Going back to the schedule, after solution chemistry, which is really important that you know how to do calculations. We also do a solution exercise in lab so that it will be ingrained on how to do these calculations. We do kinetics. Now, kinetics, equilibrium, thermodynamics, and the other topics that are covered in this class, they tell you a story. They tell you a story about how reactions come together, the physical process of reaction. Like I said, that's why I like Chem 201. Kinetics tells you how fast a reaction goes to not so much completion, but to equilibrium, when it looks like the reaction has stopped. Equilibrium tells you when the reaction has stopped, but more importantly, it tells you the efficiency of that reaction. And that's the next topic after kinetics. And then acid-base is nothing more than equilibrium for a specific type of chemical, acids and bases. And then thermodynamics tells you the story as to whether that reaction is going to need external energy, whether it can take place without putting in energy, or whether you have to invest energy to get that thing going. It'll also tell you whether that reaction is impossible, okay? No amount of energy will get that reaction going. So again, that's what Chem 201 is about. It's about these main 4 topics that kind of are in sync to explain reaction. After kinetics, we have a quiz that covers kinetics and solution chemistry, okay? And the quizzes are generally open on a Friday and close on a Sunday, okay? So I give you that time window where I know that a lot of you do work, so I try and do the quizzes. And these are, I believe, 100-point quizzes, okay? So you might even think of them as exams, where you are trying to make sure you understand the fundamental of that concept. So I think I give you like a 90-minute window to complete it, and it's going to be on topics that we've covered for that particular section. So quiz 1 will be solution chemistry and kinetics. Quiz 2 will be on equilibrium. Your midterm will be on everything including acid-base chemistry. Okay, and acid-base chemistry is nothing more than equilibrium for specific chemicals. So that's what you see right here in the schedule. The midterm is scheduled for in class on October 28th. That's, no, that would, yeah, October 28th. That's what my schedule is. Let me take a look at my calendar because I was getting confused between this class and my other class that I was preparing for. So let me take a look at my calendar real quick. The October 28th is a Wednesday, and you guys are going to be taking it at the time we meet. Okay. Now, this class is being offered between 5 and 6:30, so you got to make sure that you're free at that time. If not, please register for Dr. Sinkaset or Dr. Nanda's course or some other class because guys are expected to meet here at those times, and we'll go over the topics that we have. And also, the midterm on the 28th is scheduled for our during our class. So keep that in mind. After the midterm, we cover thermodynamics and electrochemistry. Electrochemistry is nothing more than electron transfer. Acid-base chemistry is about proton transfer. But electrochemistry is very related to thermodynamics. When you run a chemical reaction and it's spontaneous, it gives you electrochemical potential. There's a driving force there. If it's not spontaneous, and that spontaneity is a thermodynamic phenomena, if it's not spontaneous, then it gives you a negative voltage, and the negative voltage simply means that that's the amount of energy you need to input to get that reaction going. So that's why thermodynamics and electrochemistry are covered in the same exam. Then after that, we go into transition metal chemistry and nuclear reaction. Then you have your final. Your final is scheduled because of the problems that we had last spring on a Friday between 1 and 2. So you're not going to meet on Monday because our semester runs up to the 14th of December. So we're instead going to meet on December. It's a Friday where nobody should be having any labs or lecture. If you are taking a course outside of Miramar and it meets on that, then we need to talk, okay? But that's when your ACS exam is scheduled, and everyone at Miramar College is going to be taking it at that time. That way there's no copying of the exams and sharing it with friends. Again, we've had a really bad time last spring where there was massive cheating. And so in order to prevent that, rather than do some sort of lockdown or have you guys open your Zoom and we have to like look at you taking the exam, we're just going to sort of limit it to this time period on Friday, December 11th, and everyone takes it at the same time, okay? So that's the schedule. There's Thanksgiving break in there on November 23rd. Hold on. Close my door. There's also a couple of holidays. We have Labor Day on the 7th of September, and we also have Veterans Day. That's why our semester goes to the 14th Monday, because we have a couple of missing days there that needs to be made up. Anyway, moving along on this course syllabus, just double check the chat. Okay, nothing new in the chat. These are the dates at the bottom here, important dates. If you need to get out of this class without a W, August 28th, 2 weeks from, well, 10 days for that. If you are enrolled after the 28th, then you can still withdraw on the 23rd of October and you get a W. But if you want your money back, you need it by the 28th. And then, of course, these are the other dates that are important. A couple of other things is that, like I said, this syllabus was originally written, the SLOs, the attendance policy, based on you guys coming to class. But since we are doing remote, you got to ignore those topics that says that, yeah, we're going to take attendance. I'm going to call you guys and make sure you're here and you're going to sign a row sheet. That's all tossed out. Okay, so please keep that in mind. The other thing I want to mention, and it's probably mentioned somewhere in the syllabus, is that when you do take an assessment, let's say you're doing the survey, and I tell you it's 5 points. Some of the questions, maybe some of you already know this, if you've seen how Canvas works, is not graded, and so you won't see a score. That's because some questions are open-ended, and because of it is open-ended, you either need to put in the exact character that the students will type in, and then the Canvas will say, yeah, that matches exactly what the author of that question wants the answer to be, or it'll mark it wrong, or it won't grade it. So when you finish a test and you see a score and it's lower than expected, keep in mind that I need to go in and grade it by hand and double check everything. Sometimes I miss things, and you guys are not going to, you guys will surely remind me about that. Okay, but please keep in mind that the initial score that you see in any of the assessment is just the score based on Canvas grading it. I need to go in and grade it, and then when I release it, I'll usually make an announcement, and you see it. Then if you have questions, then please you can talk to me via email or we can Zoom. Okay, so please keep that in mind. There are other information here in the syllabus, and you guys can read that. You guys have a syllabus quiz, I think next week or the week after, and so keep that in mind. In terms of class reading, chapter reading, you guys know the chapters we are covering based on that text. In terms of the homework, I think I explained that in my lab and mastering. You guys need to see, you don't have to do the prime, you don't have to do the recommended problems at the end, but the homework is worth 10 points, and if you get 10 out of 10 on that, then you don't really need to do prime. But the prime's there just to kind of give you a hint of what the chapter is going to be covering. Okay, and the post-lab questions or the post-lecture questions, post-homework questions is there just so that it gives you more exercise on those topics that you are weak. Okay, it's called adaptive learning. So the adaptive questions are the questions that the artificial intelligence will recommend to you based on what you miss. Okay, so there are basically 3 sections for every homework, and all you need to do is get 10, and you will have scored perfect for that. There is no carryover in terms of you got 12 or 13 out of 10, you just get 10. But that should mean something, meaning that you've mastered that material. Okay. Again, the attendance policy here really may not apply except for the online portion. Your attendance really is based on you guys coming into Zoom and then logging more or less into Canvas and submitting your assignments. Okay. Again, we have 4. Let's see where the breakdown is. Here it is. Okay, this is the breakdown as to what how things are broken down. We have chapter 11, 13, and 14. 11 again is intermolecular forces, 13 solution chemistry, 13 solution chemistry, 14 is kinetics, and that's covered in quiz 1. 15 and 17 is equilibrium. They do heterogeneous equilibrium in the second half of chapter 17, but that's still an equilibrium process. So that's on quiz 2. 16 and 17 is acid-base chemistry, so that'll be the main portion of your midterm, but I also throw in um, the beginning of the course in that, okay? And you need to know equilibrium anyway and solution chemistry anyway if you're going to be working with acid-base chemistry problems, because those are the fundamentals that you really need to understand to solve those types of problems. 18 and 19 is electrochemistry and thermodynamics, and then 22 and 20 are transition metal chemistry and nuclear chemistry. Okay, here's the grading breakdown. Again, 650 points out of 1,000. I always like to base my course out of 1,000 points. That way, at the end of the semester, if you've got 910 points, you know that's 91%. If you've got 640 points, you know you've got 64%. So it's an easy math. So I just adjust my assessments, my assignments, so that they all add up to 1,000 points. And there will be opportunities throughout the course where you can get extra bonus points. Okay, what we'll do in some of the Zoom session is that we'll talk about a topic, we'll go into these breakout rooms, and then you guys as a group will work on a problem, turn that in, and then you guys will have credit. I see someone has a question. If you want to unmic yourself, or if you want to put it in the chat room, chat box, then you can go ahead and ask questions. And feel free to interrupt me at any time. Okay, I want to make sure that you guys understand that this is like a regular classroom. When I'm speaking and you have a question at the moment, please ask, because you might forget that question later on. So,
okay. Hi there, Professor. So on the screen right now, it says that the midterm exam is scheduled for October 28th from 6 to 8 p.m. And it says during regular class time.
Yeah, I think I missed that up. It should be 5 to 6:30. Sorry.
Okay, perfect. I just wanted to confirm that it wasn't during that time, because most of us, I think, have lab at that time.
I know we have a lab at 6:30, so I apologize for that.
No worries. Thank you.
So depending on how much time I want to give you, we might even start earlier. Okay, or I might even give you a window. Say we start from, say, 5 to or 4 to 8, and in that window, but it has to be a specific window. Okay, you have 2 hours. So that'll be it, but it'll certainly be contained around our class meeting, so that for those of you who do have courses or labs in another section, you can still take it within that window. Okay, so thanks for letting me know about that. And then the rest of this is just information about making sure that you guys are learning, staying on topic, keeping to the deadlines, collaborating with others, but not cheating with others. Okay. So you guys can read that, especially the honesty policy, because again, the department were just irritated based on basically it didn't do a lot of the students who were right at the edge any good, because the students who were dishonest really pushed the curve up. So keep that in mind. You guys can read through all of this, and again, you can see where I've crossed things out because it doesn't pertain to the remote learning environment, but certainly look at that. The most important thing out of all of this is conditions for being dropped. Okay, even if you don't have anything in your assignment, you try 1 or 2 problems, turn that in. At least you get a point or two, even a point or two for trying. But if you don't do 3 consecutive assignments, basically tells me that either you've lost interest in the course or something's happening. I'll sort of reach out to make sure that you're still with us. But usually I will contact you to see whether or not you're still surviving, and if I can't contact you after that period, then we will have to just drop you. Okay, because it's better to get a W than an F, because if you are in the course after the withdrawal deadline, and you don't have the necessary um, skills, or you don't have the percentage to pass, then at least if you don't pass, you fail, you can repeat the course, and your transcript will give you the better grade when you repeat the course. Okay? And sometimes for those of you in medical school who wants to pursue medical school, a B or an A is better than getting an F. So when you withdraw, then you won't get that F. But know also that if you do fail a course, you can always repeat it. Okay, but you have to fail the course. I don't know how that reflects in your transcript, but I think your GPA is reflective on the better grade. Okay. Anyway, going back here, these are just key things that I found in Quora about making sure that you don't shortchange yourself, and making sure that you keep up with the work, and how to effectively remember things. Because I know that a lot of you want to go into medical school, okay, or some sort of postgraduate program. So this is your life for the next, this is second semester, 6 years, 2 more years of university, and then 4 years of med school. So you have to train yourself. You got to make it a habit to understand the fundamentals. And then the honesty policy. Make sure you read this. There's going to be a lot of questions on the honesty policy in your syllabus quiz. Syllabus quiz will not be released until next week. Okay, so don't be looking for the syllabus quiz until next week, because I want you to digest the material first and get a feel for how this course is run. Then this one was just sort of released to us by the Vice President of Student Affairs, just based on the fact that a lot of students are not dishonest, but they don't understand the difference between being dishonest and collaboration. So this particular page kind of makes that clear as to what is collaborative learning and what is dishonesty. So you want to read this because, again, if you are passing work as your own that someone else did, or that you're copying from somebody, or you're stealing answers, then that definitely falls into the realm of dishonesty. So this is the syllabus. This is it's our contract. It's the contract that I will try and live by in terms of teaching this course, and you guys need to remember that the expectations are here. Okay, so let me go ahead and change page here, because I want to go next to this right here. If you guys have any questions, please feel free to fire the question. Okay, so this is the other topic that I will go through, and then we'll be done. I'm not really going to go into chapter 11, and then I'll be working on making sure that all the links are up to date. But stuff you should know from Chemistry 200. So let me go ahead and do that. And this is just a review, okay? But it's been a while. If it's been a while since you've had General Chemistry 1, then these are the things that you want to look at and look back to make sure that when we reach a topic in Chem 201, you already have that fundamental down. So in terms of this, what did you learn in Chem 200? And this is where we usually will break up, and I would give you an index card, and you guys would write down what one thing or two things that stuck out Chemistry 200. So anyway, we can't do that here. I could probably do it, but in the course of time, you guys can just do a thought experiment and write that on your own. But these are the most fundamental things that you will need from first part, general chemistry, and then I'll get to more specifics later. You need to know the gas laws. And the reason why you need to know gas laws is because when you do equilibrium, you can do the equilibrium for solution chemistry, you can do equilibrium for solution phase. And you need to remember that within PV equals nRT, there's a V and an N in that equation. The N is the moles, the V is the volume, as you guys know. So if you take N over V, guess what? That's a concentration, moles per liter. So you can easily convert the mass of a system or a concentration of a system to pressure through PV equals nRT. And that's what you will remember in gas law calculation, PV equals nRT, the ideal gas law. You should also remember the Maxwell-Boltzmann distribution plot, because the Maxwell-Boltzmann distribution plot, which tells you the energetics of chemicals at a certain temperature, that kind of tells you something about kinetics. It tells you how many of those chemicals actually have enough energy to bypass the activation barrier. So that's part of gas laws. Dimensional analysis is just so fundamental in everything. Even if you don't have the equation, if you know how to do dimensional analysis, you can set up the equation that way. Of course, we're using metric systems and always carry your units. Chemical reactions and stoichiometry is important because we're looking at reactions here. We're looking at chemical reactions as they come together, or chemical reactions as something starts to break down. And so with chemical reactions, stoichiometry, you need to know the language that we speak, the chemical nomenclature. So again, these are the fundamentals that you need to know. For intermolecular forces, chapter 11, you need to remember phases of matter, solid, liquid, and gas. Did you know that intermolecular forces is the reason why we do have the solid and liquid phase? Without intermolecular forces, everything would be in the gas phase. Intermolecular force is the glue that makes chemicals stick together. When they stick together, then you can get a gas liquefying. When they stick together, you can get a liquid solidifying. Okay, how strong those intermolecular forces are depends on the chemistry that locks them together, but you can overwhelm them by adding energy. Okay, so the type of intermolecular forces that you guys hopefully remember or will learn is called London dispersion force. London dispersion force is just because these chemicals have electrons. Since all chemicals have electrons, all chemicals have London dispersion force. It's a force, it's an intermolecular force that exists for all states of matter, okay? For all chemicals with electrons, not for plasma. Plasma is not a state that we're used to. Plasma is basically a chemical in which the electrons are stripped. But if it has electrons, it's got London dispersion force. Dipole-dipoles for polar chemicals. Now, a chemical could have London dispersion force and dipole-dipole. In fact, if it has dipole-dipole, it also has London dispersion force. If it's got hydrogen bond, it also has London dispersion force. Because, again, like I said, London dispersion force exists for all chemicals. Dipole-dipoles for polar chemicals. It's like a magnet coming together. When you put a magnet together, the north side of a magnet is attracted to the south part of the magnet. Chemicals with a partially positive will be attracted to the partially negative end of a chemical. That's what dipole-dipole is. Hydrogen bonding is a special bond when hydrogens bonded to an electronegative element. You guys will need to know how to recognize that, since hydrogen bonding is really important in your MCAT, okay, and biology. Let me tell you a secret. If you got a chemical that has hydrogen bonding, then it's also polar, which means it also has dipole-dipole. And since all chemical has London dispersion force, when a chemical has hydrogen bonding, you check mark all the boxes. London dispersion force, dipole-dipole, and hydrogen bonding. Okay. Ion dipole is a force in which if you take salt and you put it in water, that's how salt dissolves. It's through the ion dipole intermolecular force. So these are the things, the key things that is covered in chapter 11. We also have a heating cooling curve. Heating cooling curve just kind of gives you an idea of what phase we have depending on the temperature by which that substance is going to be um, um, imposed on. Okay, a phase diagram. You're not only looking at the temperature, you're also looking at the pressure. So those are the topics that's covered in chapter 11. The next section here is chapter 13, solution chemistry. Here you need to know a little bit about nomenclature, okay, the formulas, the chemical reaction. Sometimes when you're forming a solution, okay, especially the solution generally has a solute and a solvent. You got to make sure that the solute dissolves in the solvent, otherwise you're never going to get a solution. So you need to know a little bit whether or not it might interact with water and mess things up. You need to know a little bit about intermolecular forces. You need to know about solubility rules, and of course, moles, molarity, and moles per liter. I think you guys covered molarity in general chemistry. That's what chapter 13 covers. Kinetics, well, that's a Maxwell-Boltzmann distribution curve, and then you need to know some of the fundamentals of concentration calculations. You guys also covered thermochemistry in general chemistry. If you covered thermochemistry, you need to know about exothermic and endothermic system, because that's part of kinetics. Okay, whether or not the product is higher energetically or lower energetically than the reactant. Okay, so those are the topics that you guys need to. Those are the fundamentals. Those are the key topics that you guys will need to know as we hit these chapters. The next topic here is equilibrium. Equilibrium is probably the most important topic in the whole course, just because everything's based on equilibrium. Okay, you need to know about gas law. You need to know about solubility rules. Remember solubility rules? It tells you that if you got an alkali, group 1 or group 2, heavy group 2, and you put it in water, it dissolves. It doesn't tell you, however, how much of it dissolves. Because if you take sodium chloride, and that is very soluble in water, and you put it in water, there's something called a solubility limit. You can only put about 32 grams of sodium chloride per 100 grams of water. Anything above that, the solid salt will not dissolve. Actually, it's in dynamic equilibrium. As some of it dissolves, some of it precipitates out. But we'll talk about that in equilibrium. Anyway, the reason why I'm telling you this is because the solubility rules never quantifies how much of it actually dissolves. Well, guess what? Chem 201, you guys are going to do that calculation and tell me if I have, say, 200 grams of some solute, you can calculate how much of it remains as a solid when you put it in water. You can actually calculate how much of it dissolves. And so that's what we're going into here in Chem 201. You guys will get a numerical value rather than just saying, yeah, it's soluble. It's not soluble. You're actually going to quantify it. Even for things that are not soluble, you can calculate how much of it actually goes into water. And it's going to be very small, like 10 to the minus 30th, okay, of it will go into water. And that means it's hardly soluble, but you can still calculate a number. You certainly need to know about stoichiometry, concentration calculations. You can see again how important knowing how to calculate concentrations are. And then, of course, thermochemistry. Acid-base chemistry, now we're looking at specific chemicals, one that has hydrogens to donate and ones in which it can accept hydrogens. So you need to remember their Lewis structure. You need to know about valence shell electron pair repulsion, because you need to see how the structure correlates to which hydrogens are loosely held and which hydrogens are tightly held. Because the more loosely held a hydrogen is to a structure, the more acidic that particular chemical. Because what is an acid? It's a chemical that wants to donate its hydrogen. So the strongest acid are those chemicals that holds on to its hydrogen the least. Okay, it doesn't have a very strong grip. Whereas those chemicals that are non-acid, they don't let go of their hydrogens. Okay, so again, some of the fundamentals, and everything's a build-up. You need to understand equilibrium if you're going to appreciate acid-base chemistry. You certainly need to know how to do stoichiometry, and I think you guys also did a little bit of titration in Chem 200. Well, you're going to do it here again. Now, unfortunately, your class has been sort of, well, how can I say this? You've been sort of like, sort of shortchanged in your training, because if you took Chemistry 200 in the spring, you didn't really have the full lab experience, and you're definitely not going to get the full lab experience here. Okay, so when you go into organic chemistry, when this old COVID stuff is done, it's going to be that much more difficult to get into organic chemistry, because some of the fundamentals that you guys are building up, the handling of glassware, the handling of chemicals, well, general chemistry is where you guys learn that fundamentals. If you never really handled the glassware as often as you should, then it may be a struggle in organic chemistry. Okay, and organic chemistry, that's a lab-based course. So I don't know how they're teaching it this semester. I think it's video-based, but and all universities are doing that, but it certainly shortchanges you in terms of that experience, and we apologize for that. You know, everyone's in the same boat. So again, acid-base chemistry is in that realm. Thermodynamics. Thermodynamics, I love thermodynamics. I used to be a chemical engineer. I got out because, well, I just didn't like the topics or the way it was explained. So instead of going for chemical engineer, I got my PhD in chemistry, which actually wasn't too bad. But thermodynamics, whether you're in biology, physics, engineering, chemistry, thermodynamics is one of those sciences that is really important, because you need to know about the efficiency of the device that you're making, or the efficiency of a system that you're studying. And that's what thermodynamics is. It tells you whether or not it's going to give you energy, or you need to put in energy. Okay, so you need to know about the structure of the chemicals. You need to know about some equilibrium, so you can understand the chemical reaction that takes place. You need to know whether that reaction is exothermic or endothermic, whether it releases heat or absorbs heat. Remember Hess's law, that the steps in the path is equal to the overall path. Okay, and then you need to know a little bit about intermolecular forces. So hopefully I'm jarring your memory in terms of the chemistry that you guys learned in Chem 200. If not, these are the topics, and all my notes are online, so you can just download them. These are the topics that will really help in terms of you guys mastering the fundamentals. Electrochemistry, you had a little bit of redox chemistry in general chemistry, I hope. It's about electron transfer. It's about whether a chemical becomes negative anion because it gains electron, or positive cation because it lost electrons. Okay, and there's actually a driving force for that to occur, and that driving force can be read as an electrochemical potential. These are the topics that you will need, and again, you can see that equilibrium is always one of those topics that you will need. That's why we introduce it early on, because it's part of all chemical reactions that we're studying. After that, we look at coordination chemistry. I'm actually an inorganic chemist by training. I did my graduate work at UC Santa Barbara, and these chemicals that you see right here, this example that you see right here, I've studied those chemicals. Mine has an iridium right in the center, the chemical all the way to the right, where it has ruthenium and these pyridine rings on them. Well, I studied these types of chemicals, and we thought we were big when we were studying them, when I was studying them at UC Santa Barbara. The idea of my research was that these things absorb a lot of energy, and so we can shine light on them, it will absorb it and then transfer it to a substrate like water, and then split water so that you get hydrogen gas. And that's where we're going these days, the hydrogen economy. Okay, everyone's talking about fuel cells. Well, guess what? Fuel cells use hydrogen. The shuttles, the space shuttles that we had in the 90s and 80s, they use hydrogen and oxygen to produce water, and that was fuel cell. Well, after electrical vehicle, there's these companies these days that are trying to do this, but hydrogen is not cheap. Okay, we need a well, water is cheap, but hydrogen, making it from water, is not cheap, and we need to find a system that can do that efficiently. Well, that was what my research was. Funny thing is that some Japanese worker took these same chemicals, and instead of shining light on them, they ran electricity through them. And then they found out if you run the right voltage of electricity, these things shine brilliantly: green, orange, red, blue. Guess what these Japanese workers did, or these researchers did? They invented organic light emitting diodes with these chemicals. So the person who studied the chemicals initially are not the people who generally get the credit. It's the people who knows what to do with those chemicals that will reap the benefit. And so if you look at your iPhone or your iWatch or your TV and they use OLED, well, the chemical that I studied in graduate school has gone from converting water to hydrogen to being your color display. Anyway, I thought I'd share that with you. Okay, so they may have won a Nobel Prize, and chemistry is really interesting. But again, I like working with iridium. These things were pretty magical when I was working with them. Coordination chemistry, that's my favorite topic in this whole thing. And then we wrap off the semester with nuclear chemistry, and that is some of the fundamentals in that are found in atomic nomenclature. Okay, so we're not going to cover organics, so don't worry about that because we don't have time. So just look back at this notes again, because to prepare you for the ACS test, these are the fundamentals that you guys will need. Okay, these are the things that you guys can take a look at this, and these are the fundamentals that the ACS test is only the second half, but you still need to know the knowledge of the first half to master the second half. Anyway, I'm going to stop there. These are again available in my website or through Canvas, and be patient with me as I update the links. Okay, but that basically is what I wanted to talk to you guys about. For those of you in lab, we will meet at 6:45. If you have any questions, let me know. Again, let me just review the main things that we talked about today. If you read the syllabus, and you guys will have a syllabus quiz next week, okay, you'll see that the required material is My Lab and Mastering and the textbook by Tro. And if you don't have that specific textbook, okay, if you get an earlier edition, that's fine too. The chemistry hasn't changed. But you do need the My Lab and Mastering, because those are the specific questions that you guys are going to be graded on. Okay, so those are the required material. We meet Mondays and Wednesdays around this time. In terms of how you guys are being graded, you're being graded by 4 main things. One is the homework. Okay, each homework set, each chapter is worth 10 points, and you can get as much as 14, 15 points each, but you only get 10 if you surpass that. Then you have your module quizzes. The quizzes are based on, and it's more like an exam, it's 100 points based on that topic. Whether the first one is kinetic solution and a little bit of intermolecular forces, it's 100 points. Okay, we have 4 of these. You also have a midterm, which is the first half of the semester, and a final, which is an ACS exam. And it's, I think you get 70 questions to answer in 100 minutes. Okay, but the questions are not long, and it's not like stepwise. Remember, you get 70 questions, 100 minutes. It's probably a 1 or 2 step calculation. And then it's your participation. When you attend Zoom, that gets you a certain number of points. And then when you have our breakout sessions, I'll give you an assignment to do. You work with groups, you kind of collaborate, and those things are to help you understand the fundamentals that you guys will be seeing in the module quizzes, in your midterm, and in your final. So that's basically the grading scheme, and that's how you guys will be evaluated in this particular course. When our homework due? I usually open up the homework a week before we start covering it, and then the homework is due after we've completed that chapter. Sometimes we cover like 2 chapters per quiz that weekend. It's always due on a Sunday. And I found out early on when I was teaching online, you don't want to make it earlier than midnight. Okay, if you make it 10, too many people complain. So it's at 11:59. And the only reason why it's 11:59 is because that's the last timestamp that Canvas will provide. So generally, these things, you need to look at the syllabus, and you need to look at MyLab and Mastering, because some of the early homework might be due not on a Sunday, just because we got a bunch. But generally, if you look at those homework set in MyLab and Mastering, it'll be due on the Sunday, and it may be that the homework is due at the same time the quiz is being given, but that shouldn't hinder you, because when you do a homework and you submit it, you get the answer right there. You will know whether you did it right or didn't do it right. So to say that, oh, the homework's not due until the same day that the exam is given, well, you do the homework, and as you do each question, you can submit it and see whether or not you're getting it right or not. And if you are not getting it right, then you need to contact me so we can go over it. Okay? But generally, it's due on a Sunday, 11:59. Any other questions? If not, great having you. I will go into Zoom, find the transcript, edit out the edges, and then put it on the website, and then you guys can review it if you want. Okay? If not, then we'll see you on Wednesday.